Okay, guys, and the last couple questions were on the gas law, like calculation part. We got this guy and this guy, numbers 3 and 4. Okay, so let's go over the first one. It says a propane tank contains 25 liters of gas at 27 degrees Celsius and 3,000 millimeters of mercury. And then it asks, what is the pressure if the temperatures increase to 227 degrees Celsius at a constant volume? All right, so if we know we're at a constant volume, that helps us determine what gas law we need to use. Okay, if we're at a constant volume, we're going to be utilizing P1 over T1 equals P2 over T2. All right, now we need to make sure that our pressure units are always consistent, so P1 and P2 have the same units. As for temperature, we always have to be in Kelvin. Okay, always, always, always. You have to remember that. Okay, all right, so our initial temperature is 27 degrees Celsius. That is 300 Kelvin. Our initial pressure is 3,000 millimeters of mercury, and we can just keep it in millimeters of mercury. That's totally fine. Okay, so I'm going to plug this in. I'm going to put 3,000 all over 300, and this is going to equal P2 all over the final temperature is 227 degrees Celsius, which comes out to be 500. Okay, now in order to solve, the best way to go about this is just to simplify this side. Do 3,000 divided by 300, and then multiply by 500. Okay, P2 comes out to be 5,000 millimeters. Oops, it's supposed to be a millimeter. Millimeters of mercury. There you go. Okay, so not too bad, right? Okay. I'll let you guys take a look at that, and I'm going to erase it. All right. I'm just erasing it because I probably need more room on this question. Okay. I can just keep it in the same color, is fine, but I want to change the eraser. There we go. Okay. A 250 milliliter sample of methane is at STP. At what temperature will the gas have a volume of 500 milliliters and 2 atmospheres of pressure? Okay, so now we have all three variables. Okay. If we have all three variables and we're relating all three variables, remember that's the combined gas law. P1 V1 over T1 equals P2 V2 over, that should be a 2, over T2. Okay, now once again, we got to make sure our temperature's in Kelvin. As for our pressure and our volume, they can be whatever units you want them to be in as long as it's consistent. Okay, so STP, we got to remember what STP is. STP stands for standard temperature and pressure. Okay, standard temperature is 273 Kelvin. Standard pressure could be 1 atmosphere, 760 millimeters of mercury. Let's go ahead and utilize atmosphere because our final pressure is already in atmosphere. Cool? All right. So P1 is 1 atmosphere times V1, which is 250 mils. I'm not going to plug in the units. It just kind of takes up too much space. All right, and then this is going to be over the standard temperature, which is 273 Kelvin. All right, and then this is going to equal the final pressure, which is 2 atmospheres, times the volume, is this and this, which is 500, all over. We're trying to solve for that temperature. Okay, best way to go about this is simplify your numerators first. Then on this side, do the 250 divided by 273. And then you guys can cross multiply or solve for T2. Whichever way you want to solve algebraically, do it. T2 comes out to be 1092 Kelvin. Okay. I'm just going to circle it for you. All right. Now, I hope that was helpful. If you have any other questions, email me, Canvas message me. Remember, on the gas law problems, to identify which gas law you need to use, the first thing you need to look for is, okay, what did they give me? What am I trying to find? What's constant? Okay, all of these things will help you determine which gas law to use. All right? Okay, guys, see ya.